Okay, the next ones we're going to work on are these division ones, and you would think you divide, but if we look at these tricks, it says how to divide i's. You don't. You do multiply both pieces by the complex conjugate, which is the normal then the opposite stuff of the denominator. So those of you who have maybe taken Spanish or something, when you conjugate a verb, don't you change like the back end of the verb? That's kind of what conjugate means in math. If I'm dividing, I have to look at the bottoms and conjugate the bottoms. And conjugate means the normal first stuff, then the opposite second stuff. So the complex conjugate of this first example would be the same -4, but then an opposite plus 8i. The complex conjugate for this second example would be the same 5, but then the opposite 2i, so a minus. The complex conjugate for this last sucker would be the same normal part, and there is no normal part on the bottom, and then the opposite I, so a minus I. Okay, and what we do with this complex conjugate is you multiply both pieces by the complex conjugate of the denominator. So let's go to this first example. First, we have to come up with the complex conjugate. We look at the bottom, and it's the same normal number, 9, then it's the opposite of this -i, which is a +i. And we're going to take that and multiply it to both pieces. So even though it says we're dividing, we're not. It's a trick. We're just multiplying. And what's going to happen is we're going to get something dirty on the top, but on the bottom, it's all going to disappear to just a good old fat, normal, real number. It's going to be crazy. Okay, so why don't we multiply? On the top here, we're going to get 6 times 9 is 54. 6 times I is plus 6i. But then on the bottom, don't get cocky. We need to FOIL because there's a binomial times a binomial. 2 things times 2 things. So let's FOIL this. First, 9 times 9. 81. Outside, 9 times I. Plusative 9i. You don't have to put the plusative. Okay, inside, -i times 9. -9i. I just used parentheses because I panicked. Okay, then -i times I. That makes -i squared. But then, remember that I squared is a -1. So this becomes negative, and then instead of the I squared, we put a -1. So this fat negative in the front, I keep as a fat negative in the front. The I squared becomes -1. And then that spits out a +1. Okay, so let's write down what all this combines up to be. We're going to get 81 plus 9i minus 9i. 81 plus 9i minus 9i plus 1. And if you look at the insides, they cankle. Woo! And the bottom, and 81 plus 1 is just 82. So we multiplied this denominator, and somehow the I disappeared, and we just got 82. Okay, the last thing is, let's look at my how-to steps. We did step 1, step 2 we did, step 3 combine like terms we just did, step 6 says the I's in the bottom will disappear, they did. Step 7 says write in A plus BI, that's what we did. We got the good part first, then the I part second. Then step 8 says if it's a fraction, split it into 2 fractions with the I's out to the side, reduce if possible. So that means take this 54 plus 6i over 82 and change it to 54 over 82. Get it? 54 on top over 82. Plus, what else is on top? 6 over 82 with the I to the side. See in the how-to steps, it says eyes out to the side. Okay, then we reduce if possible, and we could try and reduce this in our head, or we could maybe just throw it in our calculator. 54 divided by 82, math, which is underneath the green, enter, 27 over 41. Plus, let's see if 6 over 82 can be divided. 6 divided by 82, then math, underneath the green button, enter. 3 over 41. With an I. Holy poop. We just divided that. Not really, it was just all about multiplication. All right, let's look on this next piece. I would multiply by the complex conjugate, which is the from the bottom. So the complex conjugate of this bottom is the same normal part, the same real, 9, then opposite, I. And I'm going to do that on the top and the bottom. I have allergies. Okay. Whew. Okay, let's multiply this. It's pretty much almost the same thing. Trickery. So on the top, I'm gonna get looks like 54 I, and then 6I times 8I is ran out of room. We'll just pretend we're over here. Okay, maybe not so over there. Okay. 54I plus 48I squared all over. We're gonna FOIL this bottom. And if you're wondering, don't we need to change that I squared to a -1? We do, you're smart, but I ran out of room, so budget cuts. Let's go. 9 times 9, 81. 9 times 8I. I think that's +72I. Yeah, it is. Okay. Innards, -I times 9. -8I times 9. That makes -72I. Lastly, -8I times 8I. That makes -64I squared. And let's change that I squared to a -1. So this makes -64. And then instead of this I squared, we're putting a -1. And that gives us -64 times -1 makes +64. Okay, now let's write all this out. We get 81 plus 72I minus 72I plus 64. Well, the 72s cancel out because they're opposites, and we just get 145. Because the 72's I's cancel out. So on the bottom, we get 145. Okay, let me just keep going. So we're supposed to have 54I plus 48I squared over 145. I just rewrote this top. But then, remember that I squared is supposed to be -1. So this turns into 48 times -1 is -48 plus 54I all over 145. And if you're asking, why the heck did you spin this top around? Don't forget that every time we write an I in our homework, the normal pretty number comes first, 48. Then the dirty number with the I on it comes second. Okay, the last thing we have to do is, oh, we just did the normal plus the dirty. That's the standard form. Now we're splitting into two fractions. So negative 48 over 145 plus 54 over 145 with a fat I on it. And you type in 145 divided by, no. You type in negative 48 divided by 145. And then you can press math, which is under the green. Enter. Oh, that didn't help me at all. Well, I'll be darned. Okay, now we're going to take this 54 over 145 and see if I can reduce that. Oh, I'll be darned. Okay, neither of those could reduce. Show dash the answer. Okay, let's look at this one on the bottom right. First, we're going to multiply by the complex conjugate of the bottom. And remember, the complex conjugate of the bottom is the bottom, but with an opposite I. So 3 minus 4i. 3 minus 4i. And then on this one, we're going to have to FOIL the top and the bottom. So I think I'm going to work on the top FOIL first. And then I'll work on the bottom FOIL. And on this type of problem, it's real easy to get confused, so try and organize yourself. Okay, let's go. Multiply. 1 times 3. 3. 1 times negative 4i. Negative 4i. What's next? We're still on the top. We haven't touched this 6i with anything. 6i times 3. 18i. Then lastly, 6i times negative 4i. That makes negative 24i squared. But then don't forget, I squared makes negative 1. So this gives me negative 24 times my negative 1 of an I makes positive 24. Okay, now let's write it all out and combine like terms. So I'm going to have big fat 3 minus 4i plus 18i plus 24. Okay, combine like terms. The normal part, 3 plus 24 is 27. Golly. And then negative 4i plus 18i is plus a 14i. Okay, now let's FOIL the bottom. And the I is supposed to disappear. So every time you do one of these problems, if the I doesn't go away on the bottom of the division, you're wrong. Okay, let's go. 3 times 3. 9. 3 times negative 4i. Negative 12i. What should I do next? Naturally, 4i times 3. 12i. 4i times negative 4i. Oh no. That makes negative 16i squared. But then don't forget, I squared is the same thing as negative 1. So that L of 4i times negative 4i, it pops out to be a good old fat positive 16. Okay, so when I write all this out, we're going to have 9 from the F minus 12i plus 12i plus 16. And the i's cancel out, and they should. Every time you do one of these divisions, the bottom i's cancel out. Or you're wrong. And I think you get 25. Okay, now let's put it on top of each other. The sucker from the top was 27 plus 14i. The sucker from the bottom was 25. Okay? The last step is to split into two fractions with the eyes to the outside. So this becomes 27 over 25. Plus sine 14 over 25. With the eyes out to the side. Hey, baby, done with that one. Woo!